Okay, this video is going to go over multiple angle identities. This can get kind of complicated, but it's not that bad, I promise. And I would suggest that you're good at adding and subtracting fractions in order to be able to do this. And then also remember your reference angles, these angles up here. So that's super important to know before we go any further. Okay, here we go. They want you to first, using these numbers, make a combination of numbers that you would know the reference angle for. So what I mean is like 165 degrees, the reference angle there is 15 degrees. There's nothing that I know using this stuff right here that will help me with that 165 degrees. You have to break it up into two numbers you would know. You would know 45 degrees, and you would know 120 degrees. Those are all variations of these three main reference angles. So that's all they're looking for you to do here for these. So like 255, you could think of it as like 120 degrees plus 135 degrees, because this 120 degrees would be like 60 degrees times 2, and this 135 degrees would be like 45 degrees times 3. I hope that's somewhat making sense. You're just looking for two numbers that are a variation of these reference angles above it. So like number 3, you could see 15 degrees as like 60 degrees minus 45 degrees. 75 degrees, you could think of it as like 120 degrees minus 45 degrees. 285, you could think of it as like 225 degrees plus 60 degrees. But be advised, these are not the only combos that would work. Like for example, 285 degrees, you could think of that as 45 degrees plus 240 degrees. Those work. There are variations of your reference angle. Okay, now when it gets to the ones where it's in a fraction form, radians, you're going to really need to know your fractions. So like pi over 12, you could think of that as like pi over 3 minus pi over 4, because that's the same thing as like 4 pi over 12 minus 3 pi over 12. So that's all they're looking for the fraction ones, for the radians. So like 11 pi over 12, you could think of that as pi over 4, which is the same thing as 3 pi over 12, plus you need 8 pi over 12, which is 2 pi over 3. Okay, I feel like this is looking a little confusing for the radians, so I'm going to write it first with non-reduced fractions. So like, here's what I mean. Number 8, you should be seeing this in terms of something over 12 plus something over 12, okay? So you could do like 9 pi over 12 plus 4 pi over 12. All right, and when I'm doing it in red here, it's just me doing it with reduced fractions. Like this is 3 pi over 4 plus pi over 3. That's all I was trying to get at. So maybe it'll help if I do the unreduced version first. So like 23 pi over 12, you need to be thinking of it as something over 12 plus something over 12. And so like this one, you could do like 15 pi over 12 plus 8 pi over 12. Notice these are still all variations of my reference angles here, okay? And reduced, this would be 5 pi over 4 plus 2 pi over 3. Okay, this next one's 17 pi over 12. I would probably do like 9 pi over 12 plus 8 pi over 12. Just like that. And reduced, that would be 3 pi over 4 plus 2 pi over 3. Okay, so that's the first part. I hope that wasn't too confusing. You're just using a multiple of your reference angle in combination with a multiple of another reference angle to get to your overall outcome. Okay, let's move on. Now they're going to want you to do some like cosine of an angle plus an angle, for example, like number 11. To be able to do this, you're going to have to use these equations over here. So what you do is, this is cosine angle plus angle. That equation is right here. And all you have to do is label the angles like U and V. And then you're just going to plug it in. So like this one, I'm going to do it down here because I don't have room. It would look like this. This is U, this is V, and now you're just going to plug them into the equation. So it would be cosine U times cosine V minus sine U times sine V. Okay, now this can look pretty challenging, but it's not that bad, I promise. All you're going to have to do is go get like cosine 30. Cosine 30 is root 3 over 2. You just got to get values for all this. Pay attention to what quadrant you're in. And if your value is positive or negative there, that's where everybody messes up. So for instance, like cosine 135 degrees, that's in quadrant 2. That's a negative if cosine's there. So cosine 135 is negative root 2 over 2. Minus, okay, now I'm working on the sines. Sine of 30 degrees is 1/2. Times sine of 135. That's in quadrant 2. Sine is positive there, so it's just root 2 over 2. All right, so when this is all said and done, you can multiply a root times a root. So like root 3 times root 2 is root 6. Don't forget there's a negative there. So this turns into negative root 6 over 4 minus, and then this fraction right here becomes root 2 over 4. Just like that. And so you can call this negative root 6 minus root 2 over 4. Just like that. Pay attention to this. You can multiply roots. That's fine. But you cannot combine different roots. You have to leave it root 6 minus root 2, or negative root 6 minus root 2. Like you couldn't combine that and call it negative root 8. Also, notice you cannot divide a root by a number. You can divide a root by a root, but you can't divide a root by a number. So this doesn't reduce, for example. All right, so keep that in mind. Okay, that was a lot, but I think that kind of summed it up. So let's keep moving. Let's do one of the tan ones. So like number 14. Tan 45 degrees plus tan 210. Okay, for this problem, I'm using no equation or nothing weird or anything like that. It's not like one of these. Do you see the difference between number 13 and 14? Sometimes they'll give it to you where it's combined in the parentheses. When that happens, you run the equation. But sometimes they'll just give it to you like this, and you just, all you have to do is go get the values. So here's what I mean. Tan of 45 degrees is 1. Tan of 210 degrees is root 3 over 3, or 1 over root 3, like this, 1 over root 3, because it is your y over your x. Okay, so and if you're wondering how I'm getting 1 over root 3, look at your reference angle here. Put your y over your x, you'd get 1 over root 3, all right? So really, you're just trying to add this right here. And this answer for most of your teachers would probably be acceptable. Now, if you want to be perfect about it, you have to write it like this, like 1 over 1 plus 1 over root 3. And you have to rationalize this denominator on the right by hitting it with a root 3 over root 3. which changes it to be 1 over 1 plus root 3 over 3. And then you would get a common denominator. And so your final answer would be 3 plus root 3 over 3. That's just being perfect with your answer. In college, that's the answer you would be looking for. In high school, you could probably get away with just this blue part right here. But don't fall for it that you have to run this equation every time. No, you don't. They're just trying to trick you here. So now let's go and look at 13, where we actually will have to run the equation. Okay, number 13, tan of 45 plus 210. All right, now I am going to be using this equation because it matches the formatting, okay? And so basically just call the first one U and call the second one V, and you're just going to plug it in. So it's going to look like tan of U plus tan of V over 1 minus tan U times tan V. Okay, just like that. All right, and so now you just go give all these things values. So tan of 45 is 1. Tan of 210 is 1 over root 3. Tan of 45 is 1. Tan of 210 is 1 over root 3. So really it's like 1 plus 1 over root 3 over 1 minus 1 over root 3. And in terms of high school, you could probably get away with having that as your answer. However, if you wanted to be perfect, you would need to rationalize your denominator for both of those fractions. And then you'll end up having to get a common denominator for both of those fractions. So it's actually going to be 3 plus root 3 over 3 over 3 minus root 3 over 3. Again, that's a little bit more advanced and you probably don't have to do it, but that's how you would handle that problem. So I hope you kind of see how you can combine fractions to do what you want, to be able to use reference angles that you know. That's the whole point of this. Okay, let's do one more and then I'm gonna call it for this part 1 video. Let's do like number 16, sure. So we've got, no, that's an easy one where you just give them straight up values. Let's do 15. Okay, this is one of the ones where it matches the format of my equation to use. So I'm going to use the equation here. Just call the first fraction U, the second one V, and go plug them in. So it would look like sine U times cosine V minus cosine U times sine V. Just like that. So you just plug it into the equation and now you can go and give everything their value. So like sine 5 pi over 3 is in quadrant 4. Sine is negative there. This is negative root 3 over 2. Cosine 3 pi over 4 is in quadrant 2. It is negative there. So this is negative root 2 over 2. Cosine 5 pi over 3 is in quadrant 4. It is positive there. So this one's just 1/2. Sine 3 pi over 4 is in quadrant 2. It is positive there. This is root 2 over 2. Do you notice how I'm thinking about if it's positive or negative every single time? That's where everybody messes up. They drop negative signs and then it's over. All right, so this first one becomes positive root 6 over 4. The second one becomes root 2 over 4. And so now you can just combine the numerators and get root 6 minus root 2 over 4. And that would be your answer. So if it looks like it matches the format of an equation, you're probably going to run the equation. If it doesn't look like it matches the format of the equation, you're just going to give these things their values. And combine. So like that would be the answer for 16. I hope you see the difference. Okay, this video is going to be a real quick part 2 to multiple angle identities. I'm going to focus only on this section right here. So these will come at a later date. That'll be part 3, but let's go ahead and get started. To handle these equations down here, basically what they're wanting you to do is take the equation and match it up using these equations and then narrow it down to just one thing. So here's what I mean. You first figure out which equation they're using. I've circled it. They're using cosine u plus v. Notice how it goes cosine cosine minus sine sine. Well, here I have cosine cosine minus sine sine. That's how I knew they were using that equation. And so once you've identified which equation they use, you just call your first fraction u and your second one v, if that's how it goes in the equation. See how it goes u first, then v. And so to get your answer, you just make it match this left side. So you just go cosine u plus v. So that'd be cosine of 25 plus 15 degrees. And so my answer here would be cosine of 40 degrees. That's it. That's all you're having to do. So these are actually pretty easy. So like, look at this next one. Let me erase this so we don't get confused. I'm going to erase this too. Okay, look at this next one. Cosine squared minus sine squared. So I come over here and I come over here and I look until I find an equation that matches up. So cosine squared minus sine squared is cosine 2u. Okay, and there's only one angle here, u. And so both of these things are angle u. And so to get this answer, I just go cosine of 2 times u. Well, u is pi over 3. So this answer would be cosine 2 pi over 3. Done. That's all there is to this. Let's look at a couple more because some of these they look tricky, but they're really not. Like, look at this next one, 19. That looks like a terrible, terrible problem, right? Well, it's not that bad. You have tan plus tan on top, 1 minus tan tan on bottom. Tan plus tan on top, 1 minus tan tan. So my equation that I'm going to be trying to use is tan of u plus v. So go call this guy u, call this guy v, and just plug them in. So it'd be like tan of u, which is 13 pi over 6, plus pi over 4, which is v. And so you have to add these fractions. You're going to need a common denominator. So 13 pi over 6 plus pi over 4. Make them both be over 12. So it'd be like 26 pi over 12 plus 3 pi over 12, which is 29 pi over 12. So that would be my answer. Tan of 29 pi over 12, just like that. See, even though it looks bad, they're not that bad. Okay, let's look at this next one. So it's a negative root 1 plus cosine 10x over 2. Well, that looks like this. It's got the negative 1 plus cosine over 2. So cosine u over 2 is the equation that I'm going to need to be using. And so your u is right here. It's just 10x. So it's really like cosine of 10x over 2, because this was u right here. And so 10 over 2 is 5, so this answer is just cosine 5x. Nothing to it. So all of these are like that. I'll do one more. we'll jump to the end because they're all basically the same thing. You just got to kind of match it up. So like I'll do number 25 next. 1 minus cosine over sine. So now I come over here, and I look for the 1 minus cosine over sine. So if you look, you find that one right here, tan of u over 2. So this one's tan u over 2. And then there's only one angle, and it's this right here, which is u. So it's really like tan of 5 pi over 6 over 2, which is really like over 2 over 1, right? And then this is where I've trained my students to flip the bottom fraction and multiply it, so times by 1/2. So this answer would be tan of 5 pi over 12. So basically match up which equation you have to use. Identify what you're going to call u and v, whatever it is, then just plug it into the first part of the equation. That's all there is to it. So hope this video helped.